It's a whole science, the study of life systems in order to design artificial systems that copy them. Life systems have solved some very sophisticated technical problems. For example, for a long time we envied the flight of birds. Eventually, we were able to make a few gadgets that could stay in the air for a while. And after a long study of the gliding ability of birds, we were able to understand some of the principles of aerodynamics and finally construct our own birds. That's bionics. Part biology, part engineering. A more recent example was the invention of the analog computer, a feat made possible by a careful study of how the human brain operates. Here's another example. Think of a barking dog chasing an unfortunate cat. The excitement and activity makes the dog's heart beat faster. The heartbeat is regulated by a natural pacemaker, a highly modified portion of the cardiac muscle. It tells every part of the heart when to beat and how fast. If necessary, this can be replaced by an artificial pacemaker, a mechanical gadget implanted in the body to provide a constant heartbeat. But there is one problem. When the body is exerted, the heart has to beat faster. In other words, our artificial pacemaker has to be able to change its beat. If it can't, the heart gets overworked and stops. By combining our knowledge of biology with our expertise in engineering, we now have artificial pacemakers which can speed up and slow down so the heart can function almost as well as normal. Today, we're able to replace a dazzling number of parts in the human body with bionic parts. And we're doing this by studying life systems. One we're studying is the porpoise. Somehow, wounds on porpoises heal without leaving any scars. By studying how nature does it, we hope to someday perform surgery and heal the human body without leaving any scars at all. It is a curious fact that some lizards can grow new tails. We hope to duplicate that natural ability so that people who lose arms or legs will be able to grow new ones. The study of bionics has revealed a fundamental and very useful difference in the needs of living things and artificial mechanisms. All living things need our environment to survive. Air, water, food. On the other hand, manufactured objects don't fare well in the environment. They rust and break down. If a living thing, be it a plant or an animal, is isolated from its environment, it dies. On the contrary, artificial mechanisms aren't limited to our environment. They can be designed to work in a vacuum. This fact has enormous implications for our future in space.
Form and void, and darkness was upon the face of the deep. And the Spirit of God...
In space, which is a vacuum, we are like fish out of water. Our machines, though, are right at home. It's no accident that the first landing on the moon was not by a person, but by a machine, Surveyor 1. The first landing on Mars was by a stationary robot, Viking 1. If you can't beat the machine, join it. This is a projected creature of the future, the bionic person, half human, half artificial parts, a human machine at home in space. This is a clock, and this is an egg, a fertilized chicken egg. The clock runs, the egg lives. The clock is a mechanism. The egg is an organism, a living thing. The clock is made of 106 parts. The egg is just one cell, yet no one has ever made anything as complex as a cell. From the plan, we can make the clock. But try as we may, we cannot make the egg, yet. We can put together a clock in 21 minutes because we have the plan. The egg can put together a chicken in 21 days, but we don't know that plan. All it takes is the plan. It's a problem of bionics. The plan for the clock exists in the minds of humans. The plan for the chicken exists in the mind of nature. This kind of thinking has convinced some biologists and engineers that some of the same principles we use to put together mechanical devices can be applied to life itself, to learn nature's plan and duplicate it, to create life. However, a chick is created and grows automatically from a hen and a rooster. It's an entirely different problem. When a rich American bought a castle in England, he numbered each brick and put the order on a blueprint. Then, he took the castle completely apart and moved the whole rock pile to the United States. There, using his blueprint, he recreated the castle brick by brick. The castle ghost had to get there by himself. If the castle had been a living thing, though, the American would have needed only one brick, because the plans for the whole castle would be in every brick. Across the Atlantic, in America, the brick would automatically reproduce itself and give the castle plans to every new brick. The castle would grow out of the instructions. Even the ghost would be in the plans. For years we've known that the instructions for living things are contained in genes. What we didn't know is how the genes are made. Now we do. The plan is contained in a giant molecule called DNA. The arrangement of elements in this molecule determines what the living thing will be. Already, we've made artificial genes for two organisms, a bacterium and the rabbit. And we're trying to make human genes. Until the present, nature has controlled evolution. One day, an animal came who may change all of that. The thinker, the one who doesn't like things the way they are. The magnificent tamer of fire, who's afraid of the dark. In the past, we could only tame nature. Soon we'll be able to change nature. To artificially change the genetic blueprint of any human. To create the exact kind of people we want. To direct our own evolution. But what kind of people do we want? It will be an awesome power. All over the world are scientists who fear what we may do with this new knowledge, and they'd like to limit further research. Others, though, think we'll muddle through, just as we always have. The writer George Bernard Shaw was once asked by a beautiful woman, "Why don't we get married? What marvelous children we'd have with your brains and my beauty." "That would be fine," he replied. "But what if they inherit my beauty and your brains?"